Hey everyone, welcome to the project presentations at Zurich. Obviously we've had a lot of wonderful talks and tracks and other content, but a big part of ZuriHac is also the projects that participants hack on. So now we wanted to give everyone the chance to kind of show what they have accomplished or not accomplished over the past 3 days. So we like to be inclusive, and even if you did something really simple or really beginner, you're more than welcome to show it off. If you added a new feature to GAC, you're also more than welcome to show it off. We're going to do this more or less impromptu, so if you feel like it, you can come over. We have HDMI, USB-C, and Thunderbolt, I think. Lightning, sorry. So yeah, just bring your laptop and show what you worked on, and if there's many people, we can sort of like start building a queue over here. Is there anyone who would like to start? Yes, good question. Also, please keep it short in case we have, please keep it limited to, let's say, like 4 or 5 minutes. And I will kind of like try to see if we're running out of time to hurry things along a little bit. But yeah, please keep it to the point. All right, thank you. We have 2 mics.
Thanks. Hi. Okay. Alrighty. So we are the HLS team this week, and we are very proud to announce that we have like 12 PRs, and some of them have already been merged. What have we been working on? We've been working on improving the language server support for CABL files. And yes, what else? We have working on the structured diagnostics, like making sure that many error messages, instead of using regexes to figure out what is the code actions that you want, we're using instead the structured diagnostics given by GHC. There's a
nice small addition that we basically could have had at any time. We hadn't done yet. So now if you have a new enough GHC and you get an error, it'll show the error code with a link to the error index. And then presumably it will yell at you and tell you to fill it in if there's nothing there. So get on it.
Okay. So I added a code action that when you have an unknown module, you get an error, and also a code action that will add it to your CABL file for you.
And look, it's reloading the session.
Just wait.
Wait.
Woo!
Oh, yeah! That definitely works all the time.
Not even close. Thank you.
Yeah.
Hello everyone. So this year the Floor project has had very nice contributions. Two of them I would like to highlight specifically. So thanks to Tomasz from the MLabs company. In pre-production we're now indexing the MLabs packages. So this is yet another package index that Flora is indexing, as well as Package Central, of course, Cardano packages, and the Haskell Horizon project. So yeah, you can, for example, look at these packages and see that that depend on package packages, as well as on each other from MLabs. So this is the concept of a namespace. It means that every package under that namespace comes from a single source. So yeah, this will provide valuable insight to MLabs because they run their own index package as a statically generated website. So they don't have any statistics or even like dependency graphs, and the Flora project provides such a thing for them. Then, thanks to Andrei Prokopenko, we have live event log profiles streamed directly at runtime from the Flora server backend to InfluxDB and Grafana. So this is all the memory objects that you may find in the Flora backend at runtime. So this allows us to really debug memory events, space leaks mostly, in production. And from a personal perspective, as a systems administrator, it is very, very helpful. This is data coming straight from the source. No need to use tricks like a procfs on Linux, for example, which do not map onto other platforms. So this is, rather portable, and I would like to thank him warmly. Thank you, Andrei. This is very appreciated.
Okay. So, hi everyone. Yesterday, Ed Kmet, who's a heavy user of inline C and inline C++, just a second. Still too small, I think. Kind of jokingly suggested that he would like inline Verilog. So we have inline Verilog now. So this is you basically can use this sort of nameless Verilog modules. This just prints out something, but I think the reason he wanted it is to check the functionality of something he comes up with in Verilog in Haskell. This is just prints hello world, so it's kind of boring. This is a simple 16-bit adder. So the adder itself in Verilog is really very simple. It's got A and B as input, and then the sum and the carry bit as outputs, and the body is just adding A plus B. And basically, the port names in Verilog get mapped to variable names in Haskell, right? So A and B are 16-bit numbers, so they're worth 16, and they're going to be those A and B variables, and the output will have to be pointer to the right type. So in this case, the type gets inferred. I allocate these two pointers, and then this will be a word 16 pointer, and this will be a Boolean pointer, giving you this type signature of two 16-bit numbers out, carry and sum, in and carry and sum out, and this code is very verbose because I didn't write it. Something else wrote it, but well, anyway, I have a quick check test that checks that the adder is the same as the addition that's built in Haskell, and then you can do something more complicated. Like this is a module, a parameterized Verilog module that does population count, and then I'm using this module here. This is something with many arguments, right? It's got many, it's got 4 inputs and 3 outputs, and some of the inputs are, 3-bit numbers, for example, and then it instantiates the popcount module twice, one with 64-bit and one with 32-bit. Anyway, it's all this sort of Verilog stuff, and you can, as you can see, you can just sort of inline it into this Haskell definition. In this case, you've got 4 arguments and 3 outputs. And then you can, oh, this is really small now. Then you can, in this case, yeah, you run the tests. Well, here it didn't compile. Compilation is pretty slow. It needs to validate the Verilog, right? But for example, here, you're checking that the Haskell addition is the same as the Verilog addition, and that the Haskell bit manipulation is the same as the Verilog manipulation, and so on. And it's already merged. So if you go on the inline C repository, this is inline Verilog set of subdirectory, and there are some limitations, of course, but otherwise it's quite a straightforward marshalling in and out. Thank you.
Is this one also, yeah, is that this one, or you can also try HDMI? Oh, yeah, HDMI is here. I guess we can try this here.
Oh, okay. Yeah. Perfect. Much better. Yeah.
Okay, good afternoon. I'm Reinaldo from Haskell Katas, and this is Code Wars when you can get 2,000 kata ready to use to make a kata with Haskell, okay? And this is a searcher. You can search the kata you are looking for, and this is this is the kata. Its name is multiply, okay, and this is when you solve this, you get this. You get the test cases, not the simple one, but based on properties, and you get a lot of code that solve the problem, okay? So the idea is to use this huge code to train, okay? And I made Haskell Kata is about a system. You can do this in an efficient way. Let's see. New K is the program is new K, and it's only it's new K, and it's help. Oh, sorry. minus help. It's a bash script. And if you copy this new K, copy, paste, okay, you get this, an editor with the test I previously copied, and then this is for instructions, and you pass. Here is the compiler, and look at me in 2 minutes of kata working. So first of all, I change this, okay, and the idea is to do some changes in the code. Maybe put some spaces here, and here. Okay, but you can do whatever other things about this, and then you save. Okay, and you here you minus. These are some instructions. -3 to save this and pass to next one. In this case, I use space strategy. I only and commit, and automatically the next code. Okay. So another opportunity. And this one is the same. I use is only putting some spaces. But the interesting thing is all this code is interesting if you see for the first time. So you can put your comment or spaces again, and change to the next one, and change to the next one, and that's the idea. This one is very simple, very strange, because I already did this code, but not because this is new. But you need to use your eye to take it to that tell this is the change. So, and this is ready to make some experiments with this code. Okay. Maybe you can put this, save, and go to next code. You need to put some comment. Maybe in this case, maybe you use the same, but and another code. This one is. Maybe you can simply hit some returns. So previously I used the space strategy, but now I use another strategy by breaking lines. Okay. Maybe another commentary, and the next one. Here is almost the same. The idea is you gain some fluently reading code, writing, and this is very simple code, but it's an opportunity to tell some things. Maybe this is new. Okay, this is the first time. Maybe you see this, and maybe you can tell this, or maybe not. It's okay. All you do with this is okay. Okay. The idea is you can try to maintain your style, or to change because you understand another one. So it's very easy. You pass a lot of code very fast. Here previous commentary, but you can change, you can put something new, etc. And that's the idea. It's fast, and this is another code. Maybe it's the first time you see this. You need to do something with this code. Maybe you can put this because you are interested in align the equals, and maybe if you this put multiply on the same, and automatically this gain are in the same column, and maybe you can tell this is a thing that is one side. Maybe you can make an experiment and change what. That's the idea behind. And well, if you are interested in this because you are reading some Haskell code without knowing this is Haskell code, and you are telling a lot of programming statements without nothing, only using your eyes. And I'm very happy to be here because it's a great opportunity to tell to you and to learn. And I'm very happy. Thank you very much.
This one is the mirror, yeah.
Hi everyone. I'm gonna give you a quick demo about a yoke. So actually, I didn't really work on this project during the weekend, but I actually talked to a lot of people and showed the project. And so I'm gonna just show a quick demo. I'll be quick. So. The main idea of my main motivation of the yoke is to bring Haskell's type system to the world of Ethereum smart contracts, no matter how you think about this crypto stuff. But my interest is actually to do with Haskell. So I actually did some experiment. I really want to actually use linear Haskell for some case that other than memory management or resource management. So I want to experiment to see if it can help in other cases, especially for the safety. So I hope I can show you something today. Quick demo. So demo one, I show that the tooling is already integrated with the existing tool chain. So because it's kind of one-man project at the moment, I can't really build the entire compiler. That's not my motivation. I really want to just leverage existing tooling, right? So I'm gonna see if I can bring my Emacs here. All right, sorry, hold on. All right. So just quick comments that it works with something called Foundry. It's a very popular development tool for Ethereum. So get that out of the way. So I'm gonna show you that how it's integrated with the existing tooling, how I change the test and see it failed and change it back, and show you a couple of utility functions. All right, so here you go. On the left side, you should be able to see the Haskell code with a little bit some weird operators. I'll explain hopefully later. On the right side, you have this t.so. .so means Solidity, so it's actually a testing framework in Solidity. So, and on the bottom is the terminal. So currently all compiled. So on the left side, it's a Haskell function, right? So on the right side, I'm testing that particular function and meantime transfer. So I have two functions I want to test. So this language on the right side should be quite close to C syntax. So I guess not much trouble to understand it. So I'm going to comment out this, right? Oh, oops. I'm just going to save. Here you go. Wow, something broke. All right, so just show that the left side and right side is actually connected. Right, I'm going to also show you that what actually it does. This loads up a REPL environment. So I will print out the target code, which is the intermediate language of Solidity. It's called a U. All right, so I have an interpreter and write the basic, generate the target language, right? So if I see the show instance, it's a bit scarier to look at, but I'm just going to show it anyway. All right. Maybe just like this. Here you go. So my approach is actually not generate a Lambda EDL cell or anything. It's actually a bunch of categories. So I spend kind of weekend talk to people and share some experience with this. So that's how I spend my weekend here. Another thing I can show is I have a different generator, right? So how about I create a preview? I misspelled it probably. Preview. Yeah, here we go. So actually, the same code is actually visualized with the graphics generator that I have. So that's a quick demo of that, but I have something more interesting to show where the linear type's about, right? So because I would really want to use linear types for some safety feature, I find a particular use case, narrow down the use case, which is data versioning. So I really want to generalize it, but it takes time. So I'm going to show you the same mint function, what is data versioning about, what's a safety feature it can contain. So let's see a type error, maybe not so obvious, right? So in this mint function, I got a balance of an account. I do X plus Y. Minting basically means I create some new tokens for you, right? So basically, I create some extra amount of token for you, right? X plus Y. Don't mind all these weird machinery. I will not explain here. So I updated the balance with a new amount, and then I do an external call. It's like a callback, right? So everything goes fine, but how about I switch the statement, the last two statements? And making sure that all right. Let's see the green first, and then I'll save it. Save the file. You already see a HLS giving a type error. I'm not going to show it for now, but there is a type error. Just trust me. All right, save. All right, so it shows a type error. Let's see what it says. It says outdated data version. I actually customized the data error so it looks better, but otherwise it's quite horrendous. So what it type system says is that somehow you are using the data that is outdated. Why? Because this function is from an untrusted external source. So this might change a lot of things, such as calling this function again. It's actually a real safety issue in the world of Ethereum. You re-enter the function. Like in C world, probably there's a similar bug in the security sense, right? So you re-enter the mint function, and you somehow make the value read here outdated. So I made a type system so that using linear type so that I detect this is actually potentially a problem. So how it works, I use last 1 minute or 2 minutes to show to insert some type host to see what type is it. Maybe that will make things clearer. So there are two hosts. One is the type of the new amount. The other is the type of the monadic. By the way, it's a qualified do monad. So, so the new amount type is something called RV0R whatever. This is actually the type, integer with 32 bytes, right? 0 is actually the version, right? Okay, but what about this fellow? So in the context of monad, so it's actually something called blah, blah, M monadically. So it expects a version of 1, however, I give a version of 0. So that's a mismatch. So type system will actually catch it, right? So that's what I achieved so far. And to not occupy too much time, I'm going to just finish it up. So I also talked to a package called CREM from Twig, because they also have some way to encode sort of a state transition, so they make some of the state transition illegal to represent. But I think there's no types checks on the vertices. I actually commented on the issue on the CREM package. If you want to know what it is, go to their package. Okay, I'll wrap it up. Future plans. Feature completion is not yet for production for building smart contracts, so I need to finish the feature. I'm going to dog food. I'm going to use it in my company, and I will use it for some side application first before using for more serious stuff. And I want to make a case. Someday I want to write some blog post about it. I want to make a case that linear types in the Haskell, there's actually orthogonal use cases. One is for resource management, which I think is very controversially maybe not so useful, some people would say. But in my case, I would like to make a case that there are use cases for non-resource uniqueness use cases. So hopefully I want to write a bit more thorough thoughts regarding why I think it is a case. But thank you for listening. Yeah.
No demo, just wanted to briefly talk about the HS OpenTelemetry project, which is an API and SDK for OpenTelemetry. So we didn't get much in the way of pull requests, but we had a lot of very productive discussions, hopefully moving closer to getting the stuff for propagating traces into SQL queries through the commenting standard closer to being done. And that was generally very good. And it's lots of industry people are interested in it. So if you're interested in it, maybe you should also get involved. That's it.
Hello, so I want to talk about being quick, so I will try to be quick. Let's see, that's the power, God. Going to come up. No, I'm not getting anything.
Do you have an HTML port?
I do have HTML, yeah. Right, let's do that. Yeah, that one. There we go. All right. So we want Haskell to be fast, but one area where we are not fast is disk I/O. So SSDs are fast, right? My laptop, I'm getting 12,000 operations per second. Sounds really good, but actually it's rated for 1 million, so that's not very good. But that is at queue depth 1. SSDs are slow serially, but fast in parallel. In parallel, with queue depth 32 on a single core, I can get 260,000 operations per second. This is Linux FIO. It's a standard I/O benchmarking tool. So this is what SSDs are like. They are highly parallel. And if you are not using them in a parallel way, you'll get the performance down there, and you want to get the performance up there. And at the moment, in Haskell, we can pretty much only do down there, because all of the APIs that we use will use the disk serially. If you have multiple Haskell threads running on the same capability, one of them does disk I/O, it blocks all the other Haskell threads. So we're down there. But there is hope. With our library that we published this weekend, the one on the right, you can get the same performance as FIO. That is the same benchmark, but run with our Haskell program. It uses quite a nice high-level API, blah, blah, blah. I won't go into it. But wait, there's more. That's not 1 million IOPS per second, and my laptop supposedly can do 1 million. You actually have to use multiple cores to get the parallel throughput on your SSD, and we can do that too. Not quite as close as FIO, but within spitting distance. So that's great. We can now do high-performance I/O, although with with an API that is okay. Actually, I'm not going to go into it. But we've published it on Hackage. You can now use it. We are using this in a project that we're announcing shortly. Look out on our blog. So we're using this, or we will be using this in production. And if you want to help hack on this, I am trying, and I have been for several years, trying to incorporate this into GHC, into the runtime system. so that your ordinary Haskell APIs for doing disk I/O will be faster, not just using this special library. So if you're interested in that, either as a volunteer, come and talk to me. If you're interested in it commercially, come and talk to my company, Well-Typed, and we'll try and help you do high-performance disk I/O. Thanks very much.
You can skip the queue. HDMI or? Yeah.
So with a fun weekend, we decided to jump on the hype train and it will come soon. And decided to code some AI killer robots inside the game. Okay, you can just run it. Yeah. And we made some kind of scaffolding to run reinforcement learning and replaced a bunch of fine Haskell code with a couple of matrix multiplications. And we have now these derpy things doing this derpy behavior. But it continuously training, and it is training right now in the background, and you can add update the policies and see if we up for something good. And the network is, I don't know anything about reinforcement learning, but I typed this into that fancy new AI library called Grenade, which came out in 2017 and requires some maintenance. So if you know about matrix multiplication and reinforcement learning and our stuff, please go help them. It's a fine, nice library. So the bots were randomly initialized, of course, and was playing for a while. One session is 2 batches on CPU per minute. So the performance is all right without any GPU stuff. And from here, anyone can apply their AI domain knowledge. So I don't know if this will be published in the main game. That's on Steam, actually. Go play it. And if you're interested, you can come to us and ask away. We can tell you about the details and where to start if you want to train some bots or help with bot tournaments or whatever else. Thank you.
Do you ever wish you could browse the source code of all the packages in your IDE with click-to-definition and all the other IDE features? I do. Right. So I've been working on Glean, which is our code indexing system we open source from Meta. I've been playing around with an index of all of Stackage. Well, I wanted to make it all of Hackage, but Stackage will do for now. At the Haskell Implementers Workshop, I demonstrated querying this on the command line. So over the last couple of days, I've been hooking it up to an LSP server and making it work in VS Code. So here we go. So this is the ASIN library. You can see we've got type on hover. Oh, I need 2 hands to do control click. All right, control click, control click, control click in a different package. Go to references, all the packages. So that's the end of my demo. You can find references. As you can see, it was pretty fast as well. So where do we go from here? Well, there's various issues with getting this all working and building, and the DB is a gigabyte, so maybe I have to build the DB and then distribute it somehow. This is all to be worked out, but proof of concept anyway.
Hi, I'm Malte. When you work in a high velocity Haskell code base like me, you probably encounter merge conflicts, and they are annoying. And sometimes you think, well, that should be resolvable automatically, for example, in imports. So I was very happy a few weeks ago when I learned about a tool called mergiraffe, merge and giraffe merged into one word, mergiraffe.org. There you can find the tool. It uses tree-sitter grammars to resolve merge conflicts syntactically, and you can even teach it that some syntax contracts are commutative, so that it is more lenient about resolving conflicts, for example, in imports, which are commutative. So this ZuriHac, I implemented Haskell support in mergiraffe, and that should arrive in the next release of mergiraffe. And it's quite a lie. I just did it in my tent over there, so not actually at ZuriHac. It took 1 hour. It's really easy to do, and if you want to add another language, I highly recommend that. And hopefully we can use that to resolve conflicts. It works with Git, it works with Jujutsu, and whatever you want to use.
2 years ago on this stage, during his lazy evaluation talk, Andres posed a question to the audience, and it went like this roughly. So we have this x equals 1 plus 2 expression, and using the sprint command, we can print this value as much as it has already been evaluated, and currently it is underscore because it is a thunk. And the question was, if we evaluate x, then what would the output of sprint x be? So the GHC as it is today displays it still as an underscore. This is sometimes quite confusing, especially for beginners, because if we take a look into the type of x, it actually has a num constraint on it, so internally it is represented as a function closure. So during this event, I have been working on this GHC feature, where if you do the same thing, it is still the same underscore because it is still a thunk. But here now, if we evaluate this and then run the command again, we can see that it is now a function closure. And to indicate that, we enclose the underscore with angled brackets and we print out the inferred type. So this is not yet merged to GHC because someone needs to review my pull request. But apart from that, that's basically what I did during the event.
Okay, so this work? I have an HDMI if you need to. Like that, it's easier. Okay. Sorry. Okay. So hello. We've been working over the weekend on a game called Swarm. It's a terminal game in written in Haskell, and yeah. So it basically looks like this. You've got a little world view and you've got a little REPL. What more do you want? You just want to program your robots using a little Haskell-like syntax. This is like a do notation down there. And what I really wanted to do years ago was to save my game. And now we can almost do that, like merge request pending. And so what I currently do is I like pull it out using like a web request, and I save it to a file. So like what you previously saw, those commands, I can now, if I can type, I can see it like this is saved with like a timing information. So we've got like when the user entered it. And now, like this is like a different same that is more interesting, but I can replay that previous session. And so if I just step through it, it should hopefully like manage to run, and yeah, it will like slowly input what the user previously wrote, so you can like debug it and step through it, and it will like input it into a REPL at the specified time. So that's one thing that happened. And the one thing that we also wanted to fix that Björn was working on was that the trees don't show the background properly, that you can see that a little gray area behind them because we don't have a way to show the background in terminal easily. So here it looks not as nice, but hopefully when Björgi connects, it will look a lot nicer.
You may not be able to tell on the... Oops. Anyway. You probably can't really tell, but this looks nicer. Maybe you can tell that. Yeah. Anyway, you can now. So this was a major refactoring because the way we were handling outputting stuff before, it wasn't really very compositional, and so we refactored it. So now we generate for each thing. We generate a thing called a texel, which is a little textual element, and those have a monoid instance, and you can combine them, and it combines the backgrounds and everything properly. So now it looks nicer. Right.
Yeah. Also, I just want to call out. We also get like people playing the game, and even other contribution that could like make the LSP protocol nicer, because we have actually our own LSP server for the language. So it's like we're copying heavily from Haskell LSP, and we'll get there eventually, hopefully. Thanks.
Hello, I did something very boring this time, but hopefully it will still be useful. I'm annoyed with the compile times in some of our projects, and I noticed that simplifying it more and more and more, even some of the most basic stuff compiles for what I consider rather slow. So with various well-typed people's help, I got some tips on what to do about that. And the first thing that we agreed on was to just make a benchmark generator. So for example, here we just have a long file with 100 data types, and then we just see which GHC does compile that, how fast. And also if you put in here, like deriving generic EQ, ORT, whatever, which of these are actually making the compile slow? It would be nice to have a little benchmark for that. So I just quickly hacked together some like Python pandas stuff that invokes GHC with various versions from Nix packages, and then you get some output. So for example, here we can see that for GHC 912, for example, comparing these various things that we derive, you can see that deriving nothing or like EQ OR and show all kind of tolerable, or let's say you do show, it's already 4 times slower than not having it. But data, for example, is like super slow. So maybe that would be something to work on in GHC. And we can also see that comparing GHC 965 to 912 didn't actually change too much in this regard. So the idea is to just first add a couple more such examples. So we see for the stuff we do all the time, how long does it take, and maybe we can improve it. And then I also want to do a little bit of like passive-aggressive benchmarking, where you put the same thing in like Go, Rust, C, and so on, and see how fast that compiles. And if it's slower in Haskell, then we can complain about it. And that's it.
Hello. I didn't have that much time this ZuriHac, so I didn't completely finish my project, but also thanks to Jussi, I'm not sure where he is, for helping me. We started from the idea that currently many languages are taking version control into account when designing their syntax. For example, allowing trailing commas is becoming very popular, since this makes diffs a lot more readable. We are trying to work on a language, a general purpose programming language, where merge conflicts are really joyful. So this is an example of the syntax. As you can see, we are using the ZDiff3 because it's more modern. It compiles down to SKI calculus. We haven't finished the output yet, but you can kind of imagine these as parentheses, and then we have an S and we have a K. So yeah, hopefully we will have some more time to work on this soon, so you all can use it in production. Thank you. Okay, I think there's no more project presentation, so we'll move over to the closing presentation. Thank you.
I don't really know what most.
Ollie? No problem.
Hello? Ah, good. It's working. Great. Yeah, hello everyone. Unfortunately, another ZuriHac is coming to a close. Yeah. Yeah, we had quite a busy couple of days. It was quite great. We had our normal stuff as well, and we tried some new stuff this time. I don't know. We tried the panel discussion today. We tried the live podcast. We tried a live coding or something. The competitive coding this morning. I don't know. Does anyone have any idea? Feedback or something? Was it good? Did you guys like it? Yeah, okay, cool. Nice. Yeah, I don't know. Does anyone have any suggestions for something they'd like for us to do next year? Or we haven't even talked about next year, but if there was a next year, what would they? Not yet, at least, yeah. Yeah? Yeah? Uh-huh. Dedicated game director.
Yeah,
okay.
Game room, sounds good.
Yeah, game room, yeah, nice. Yeah, Duncan.
Sunny weather all weekend.
Sunny weather, yeah. I'll see what I can do with my superiors, yeah, thanks. Anything else? Nice, okay, cool. Nice. So before you leave, I'd like to request everyone to make sure that you have all your stuff with you. Yeah. So last year, you probably laugh, but this is actually something what happened. I got a mail from someone. He said, "I've just arrived in Paris, and I think that I've left my suitcase in the project room. Could you please take a look?" And this wasn't like a small suitcase. It was like this. I don't know. People get a bit excited. I understand it. But yeah, make sure that you have your stuff. Good. Also, please help us give back the campus the way we got it. Yeah? So go around the rooms upstairs and in building 1 and dispose, recycle anything that you see. So the trash that you see, yeah. And help us with the common areas with benches, coffee, and stuff. So BK is the one who will be sort of whipping you to do. No. Okay. Sorry.
Alexei?
Yeah. No, that's also something. I haven't found the owner of the swimming trunks yet. Please, if any. Next year, yes. Cool. Anything else I've missed for to do before you leave? No. Okay. Cool. Yeah. So, thank you to all our supporters, our sponsors, and our community partners. Right? This wouldn't be possible without your help. Yeah. So although most of us are volunteers who run this, we need some money to fly people over and all that stuff. So buy snacks and coffee and all that stuff. So thank you very much. Also, the Zurich Friends of Haskell accepts donations in cash and kind. So kind meaning so talks and stuff and whatever you can give. But yeah, that's what keeps us alive. Thank you also to all volunteers. Could I request everyone who volunteered to come up on stage? Don't be shy, Bika.
Oh, it's only me now.
No. No. Yeah. There are 2 people still running the registration, but yeah, they also heard it, I guess.
And there are more people who helped me set up the benches, clean up the benches, so you know who you are. Thanks a lot.
Yeah, cool. Then, what about 2026? This is the time where everyone has to take out their calendars and tell me if this is okay for you. I don't know. You have washing days, Jasper, on that? Is it okay for you? Okay, cool. Yeah, okay, so let's try to make that happen. I still haven't reserved or anything, but yeah, I think that should be good. Yeah, so Jasper made a special command. I guess you put it on the...
Yeah, if anyone has right access to the GNU core utils, we would like to add this flag.
Zoe's not here. Yeah. Cool. Okay. I guess most of you are wondering, what do I do in the meantime, right? So there are a few things lined up, right? There's ZuriHac 2025. Are the organizers of ZuriHac here? Oh, okay, yeah. So then there's also BobConf in February or March of next year. So it'll be announced in October, November of this year. Yeah. And by the way, NixCon 2025 will also take place here at the Austin Rapperswil this year in September, so the first weekend of September. So that's cool. So I look forward to seeing, we all look forward to seeing you here. then definitely, or even maybe earlier for NixCon. And yeah, see you next year. Have a nice time. Thanks. Cool. Yeah.
Workshops, will they also have them next year as well, like this year?
Yeah. I mean, there will be workshops. You mean the two pre-events? I get.
It's a question for Jose.
For Jose, yeah.
We think so.
Yeah.
Bigger rooms.
Bigger rooms. Yeah. We'll try to get a bigger room. Yeah, that's a good idea. Yeah, cool. Nice. Thanks. See you.
I mean, I'm open to anything.
Ja, niemals, weil ich kann nur so, da hat er eben die Bierse wahrscheinlich. Das ist genau so.
A nice screen you. We had a question. No, it's not. Okay. Thanks.
You're welcome. Thank you.
Stop blowing it.
Just too late. You have to be on the stage. Yes.
For what?
For getting handled. For sitting and watching.
So maybe you can first do the outlet stuff. Then we can do the outlet and then let's start.